So in today's screencast, we'll be discussing command line applications and setting up Python packages for distribution, and a few tools to make this job a bit easier. First off, we'll need to create a project. So I have a project that I just pulled down from GitHub. All it contains is a folder called racks, a readme, and a main.py. The main.py contains a simple string here that simply says, hey, print these Unicode characters when you call this from the command line. So let's see and run this. So as you can see here, it can't understand what the first character is. And if you watch the screencast on idioms, I went over why that's the case. So when you don't declare, if you don't declare the encoding type, the program assumes it's ASCII, and this in ASCII doesn't mean anything, and that's why that error is coming up here. No encoding type declared, and they point you to the PEP that actually introduced on how to the way to do that. And we also added a line here to make sure we know which file to run it with. So if we chmod main.py, we can do things like this. Excellent, and it printed that out. So the application we'll be doing will be an application, a command line application in Python, which will take input with a set of numbers and output a stack for those set of numbers. So if we want to know earthquake magnitude for a particular country over the last 10 years, we can pipe that to the main or to racks, and it'll produce this little stacked graph, which is kind of cool. This is just an example and show you how to set up command line application in Python, as well as go through all the boilerplate and go through all the work of setting a package and distributing it. So first things first. First, we'll need to create a few files to make our project actually legitimate. Of these files will be a setup.py, which is for installing the package on other computers, a license file, so people using our project, since it's open source, will know what type of license they can use it under, and a requirements file, which will contain our dependencies. So we created all those files. Next, we'll need to install the things that we're going to be using. So we're going to be using an application called docopt, and we'll install that with like so. And we also will be using another one called termcolor, I believe. So let's go ahead and install those. And while that's running, I will. Okay, it's done. So it didn't take as long as I would have thought. We're gonna first go over how to create setup.py, which the file that we created here. It mainly consists of the creator of the project, the version number, ways to get into contact, details, and for command line applications, contains an attribute called entry point. In order to create packages and distribute them to other Python developers, the setup.py is required, and this is basically the installer for all Python packages that are distributed. So let's first import from setup tools, and setup tools is application which allows you to specify all the various attributes for this package. So we're going to put this around a try catch block, since all applications may not, or all systems may not have setup tools installed, but all versions of Python come with disutils, so we can do this. So it'll fall back on disutils if setup tools can't be found. Okay, that's perfect. Next, we're gonna create the setup. This is basically just a long list of arguments, so we'll have a name here that is equal to racks, the name of our application. Next, we'll have the version. Version will be 0.0.1. Later, we'll make this more dynamic by specifying another file, but that'll do for now. Description. This is just a short inline description. Racks on racks for stacked graphs. Next, we'll have a URL where it can be found. That'll be a GitHub URL, so it can be found up on GitHub. This is where people can get the source for the project. Next, we will have an author, which is me. Author email. A lot of this is just simple boilerplate that you have to put out so people can actually use your libraries and get in contact with you if they need any improvements. Install requires is the way you would specify which applications your app depends on. As we said earlier, our dependencies are docopt. Now here I would tell you not to provide a version. This allows on install to install the latest one. Unless your application needs to work on a particular one, I would just put the name in here. So for example, termcolor and docopt are the ones we depend on now, and we can simply make this dependencies down here, which is perfect. Next we need packages, and that simply means how many packages our application actually contains, and it's only one since it's racks. And that any package is any file that has dunder in it, which are any modules rather. .py. So any particular application can have their own set of applications built in, and that is where you'd specify here as well. So for example, if you needed to patch a particular version of, for let's say distutils, you could just put it in there and then list it in the packages argument. Next, this is specific to command line applications and entry point. Now this basically means where is my package, what actually gets run when I call racks from the command line. Now, from command line applications, you need to say this is what gets run on execute from the command line. So this allows us to type in at a command prompt racks and have it do something and have it take the arguments that I specify here. So the entry point says which function is called when I type in racks, like so. Right? So all I need to do here is say console script bracket and simply go racks. That's the name of the command, and racks.main, which is the racks module main method, and then we're gonna have a method called start that is invoked. And I believe that's all we need here for setup.py. So now that your package is fully set up, we have all the requirements here to create a setup thing. We will next move on to, these are all the spaces the linter is complaining about. Since it's all in a method, there's no spaces between equal signs in a method call, which is what we're actually running here, since setup is what's actually being run. Yeah, so this is just how we set up setup.py, and this should let us install and share the racks application, as well as call it from the command line. Next, we have to provide a license file. This license file says how your application can be used and shared and modified. Now, normally when I write applications, I provide them under the MIT license. You can choose other licenses like GPL or LGPL or Apache licenses. This is usually up at the discretion of the writer or author of the application, but you are required to provide a license. Generally, you should not use any particular piece of software that's open source that doesn't have a license, because then you could be liable in the future. Yeah, so this is just a standard MIT license. You can simply Google this. All you need to do is provide a date and your name, and all this just goes. You provide permission free of charge. so on and so forth. Next thing we need to do is to provide requirements.txt. So all you do is pip freeze. That'll spit out all the things you've installed. And when we started, we installed Doctop and termcolor. So all we need to do is pipe that to the requirements.txt. txt. Done. So we open it up. All our requirements are there. So when we open source this, all the users of our library have to do is to go pip install -r requirements.txt, and they are ready to go. That concludes all the files that we added to our application. Now we can go on and develop the actual racks logic. Another important thing I forgot to mention is classifiers. So when we eventually end up pushing this to PyPI, we need to be able to tell people what status that the project's in, who it's intended for, the language that it's written in, other license information, as well as the versions of Python it will support. So this is important to provide so that your program will be listed when other people start browsing PyPI, as well as just to make sure everybody understands that this is still in development and things are likely to change. Oftentimes developers use semantic versioning to signify these states of changes, but oftentimes this isn't available, so it is best to add the development status to your classifiers. If anything, be sure to provide what versions of Python that your application does support. So now that we have the entry point and the console script set up, next I'm going to show you how to run development mode of your project. So as you're writing the application, you'll need to constantly test and check new features. So I've rewritten the main.py to have one function called start, and as we've shown here that our console script here will run racks.main and the start method, and all this does is prints out the different tiers of all the blocks in Unicode. We will need to constantly be updating this and reinstalling the application. So this is simply done by one step. Instead of having to do the whole install cycle every time, what we simply do is do this. Python, once you have your setup.py correctly created, all you need to do is Python setup.py develop, which installs it locally, creates a development mode for us, so we can then make changes to our application and then we run them. So as we said here, we should be able to run this now. So there was a folder called racks, that's why that didn't execute, but we run racks here and we get an output, just like any other command line application in Python. Now that we have everything set up for the application to install and to be worked on, I'm going to introduce docopt, which will be handling our command line interface description. So this is a pretty cool application that allows us to easily describe command line applications through doc strings. So you can go delve deeper into the documentation, but we'll mostly be taking advantage of the elements here, as you can see. So our command line application will take a set of numbers. So it will be the name of our application with a set of numbers. This is basically used to describe one or more arguments to the command line application. So I've written up an example here. So as you can see, the usage of our application will be racks and then X amount of numbers. So 1, 5, 6, 7, 8, 9. So as you can see in the examples here, this is an example invocation of our application. -help will output a particular thing. So what docopt does is simply looks at the doc string for the file, and under docked means this portion of the application, creates an arguments, and then we simply print the arguments. This only runs if the application is invoked in the correct manner. So let's go ahead and install this and see how it works. So we're going to go back out to the setup.py. We're going to go Python setup.py develop. It's going to install. Now we're able to let's go to cd into racks. We're going to go racks. So as you can see, we didn't provide any numbers, so it outputs us the usage for the file. And let's go, I think we have this set up, but it does output, one second, does output the help. As you can see here, if we do racks help, it'll output the usage as well as an example and as well as how to look up the help options, which we clearly showed there. So if we were to do this with racks with 5, 9, 6, 8, 10, it'll go and then output dictionary of arguments, which is of the numbers, and a list of digits here. So this gives us some numbers to work in and allows us to work inside the start method to output the result that we need for our application. So Doctop is one easy way to go about creating command line applications, and we could then variably add more and more usage commands. So we can specify a file, we can specify a pipe that will get piped in, but to keep this example simple, we will simply accept a list of numbers. In the previous iteration, we saw a dictionary of numbers like so, which had a key of numbers with a list of strings as its argument. So we've progressed our example a little bit. We used the get on the dictionary that returned by docopt to get us either the list of number strings or none. If the get returns us a valid list of strings, we then map each of those strings to numbers, and then we call normalized numbers. We will get to that method in a second. If that mapping fails, we then print using termcolor. Now this is the second of our dependencies, which allows us to print to screen with different types of colors and or backgrounds. Now the usage of this is pretty easy. All we do is import cprint, and we specify which color we would like our text to show up on the screen. As you can see here, this example uses green text on a red background, which then will print hello world. But as a standard in command line applications, it is customary to have a red for an exception. As you can see, if this were to happen, the user passed in something other than integers. Therefore, this is printed in red. Racks only accepts integers. That combined with the utility of docopt, we have covered all of our use cases for errors and all the possible help and version calls for racks. That being said, let's discuss normalized numbers. Now, given a list of numbers, any type of numbers, they could be from 1 to 100, 1 to 1,000, any list of numbers, we need to normalize these numbers to fit within the 7 stacks that we may have in our steps list here. So we have 7 types of Unicode strings to signify different levels of numbers. So in order for us to describe all the numbers possible, we somehow have to take the set of numbers that we were provided and map them down to 7 possible attributes. As you can see here, we have from 0 to 6, which is the same as 1 to 7, which is a len of 7, which each represents one of the Unicode blocks that we have here above. So in order to get a step range, we have to take the highest number in our list of numbers and subtract it from, or have it subtracted from the lowest number of our number in our list. We will always divide by 6 since that's the number of options we have here. So we have a step here, which then allows us to get for n in numbers. So iterate over the numbers that we have, take the first number that you get, subtract it from min, and then divide by the number of steps, and then round that down. So if this is by 0 division, it'll return 0, and then we cast that to int, and then we use that to index our steps. So this will return a number between 0 and 6, which will then be used here to index our steps for each one of our Unicode blocks. We then join those again with a space, which will result in our stacked rack graph, which will then be printed in green. So we've run through all of the examples here, and this will hopefully print out a desired stack graph given a list of numbers. So seeing as we used our setup.py develop, we only need to save our files in order to see our changes. So let's simply go racks, and let's provide an invalid input. Excellent. It says that it only accepts integers, which is awesome. So let's run this again with -v, which will, sorry, rack is not a command, rax is our command. -v, that'll return us the version. -h will return us the usage. And now let's specify some numbers. Again, it is the application is called rack, not rack. Had an H there at the end. Awesome. So you can see that it prints out each of the blocks as it should, in turn, by their number representation. So let's say, for example, we were to add a 10 here. Everything else gets shifted down. So as you saw here, the 7 previously was the highest one, but it's now the second highest one due to the steps, the step variable here, which shifted it all down so that the 10 would be the highest level block, and then everything else will be shifted downward as such. So as you can see here, we've written a small command line application using Python, using docopt, and having different types of string terminal colors using termcolor. Next talk, we will talk about distributing this particular application, as well as other tricks for helping out your development process as you go through sharing and developing Python packages on PyPI.